Okay, so let's start with this big question. What is science actually telling us? Is it, giving us a perfect snapshot of reality?
Or is it maybe more like a really, really good toolkit, something incredibly useful for predicting things, building stuff, but maybe not a literal description?
Yeah, exactly. That tension is what we're diving into today, right? It's right there at the core of the philosophy of science.
Absolutely. What is science fundamentally doing? And, crucially, how does the idea of reality fit into that picture based on what science finds?
And that's our plan. We're taking this deep dive, guided by the source material you've provided, which really lays out the philosophy of science landscape.
Hmm.
Our mission, basically, is to explore some of those huge foundational questions, and specifically get into that really interesting spectrum between scientific realism and anti-realism.
Think of it as us walking through this material together. We want to pull out the key insights, help you really wrestle with these ideas, not just, list them.
Right, so that by the end, you have a more sophisticated way of thinking about it all.
Exactly. A more nuanced perspective on science, its theories, and what we even mean when we talk about reality in a scientific context.
Okay, let's jump right in then. First base. What actually is the philosophy of science? And, maybe more importantly, why should someone, outside of academia care?
Good question. So, at its heart, philosophy of science is science looking back at itself. It's the critical examination of the scientific enterprise.
So it's not doing the experiments, but asking about the experiments? Kind of.
Precisely. It asks about the foundations, the methods science uses, the implications of findings, and importantly, its limits. Big questions like what actually counts as science versus something else.
Like pseudoscience.
Yeah, or just non-science. And how do theories and models work? What's the real relationship between observation and the theories we build? How does science even change over time? Your sources really set up these fundamental puzzles.
And it's not just thinking for thinking's sake, the sources argue. It has real-world relevance.
Oh, absolutely. These aren't just abstract philosophical games. How you answer these questions, even implicitly, affects how you understand scientific claims you hear every day.
How you trust them.
Exactly. How you trust them, how you apply them. Think about it. Medicine, technology, climate change discussions. We're flooded with scientific information. Understanding the philosophy behind it all gives you a better toolkit, really, for navigating that information overload. It helps you evaluate claims more critically.
The sources also bring up this idea of scientism as something to watch out for.
Right. Scientism is basically the view that science is the only path to real knowledge, that only scientific claims have validity.
And the problem with that is?
Well, the sources suggest it's an overreach. Science is incredibly powerful for its domain, the natural world. But philosophy helps us see it might not have all the answers for, say, ethics or meaning or subjective experience. It puts science in perspective, highlights its assumptions and boundaries.
Got it. So thinking about the history then, where did this systematic empirical approach really start taking off?
Well, the sources point back to figures like Francis Bacon.
Yeah.
He really pushed for, systematic observation, collecting data carefully, learning from the world itself, empiricism.
Learning through experience and experiment.
Exactly. And that mindset was fuel for the scientific revolution. Copernicus, Kepler, Galileo, Newton.
Right.
They were building these new models of the cosmos based on observation and mathematical description.
And a central piece of that process is the hypothesis, right?
Absolutely. A hypothesis is basically an educated guess. It usually comes from observations, and crucially, it has to make predictions you can actually test.
So you test it, see if it holds up.
Right. You design experiments, gather more data. And if a hypothesis survives a lot of rigorous testing, and it fits with other things we know, it can eventually grow into a scientific theory.
And we need to remember, theory in science doesn't mean just a guess.
Not at all. It means a really well-substantiated explanation built on a ton of evidence. But science isn't perfect. The sources also emphasize its limitations.
Like what?
Well, the scientific method, in its most straightforward form, works best for things you can directly observe and repeat in controlled settings.
But science studies things that aren't like that too, right? Like cosmology or evolution. You can't exactly rerun the Big Bang in a lab.
Exactly. And the sources discuss this. For those kinds of irregular or non-repeatable phenomena, science has to rely on different strategies.
Such as?
Accumulating indirect evidence, looking at historical traces, building complex mathematical models, simulations, that sort of thing.
So it's moving beyond simple observation.
Right. It shows how much of science involves constructing these complex theories about things we can't directly see or things that happened long ago, and that naturally leads us into this core philosophical debate.
About what those theories are actually telling us. Are they describing reality as it truly is?
Right.
That's realism.
That's the realist position, yes. Scientific realism suggests that our best, most mature scientific theories are approximately true descriptions of the world.
And the things they talk about, like electrons or genes, even though we can't see them directly.
They actually exist out there, independently of us. That's the realist view.
And the big argument for realism is the success of science, the no miracles argument.
That's a really powerful one. It basically says, look, science works so well. We predict things with incredible accuracy. We build amazing technologies. We manipulate the world based on these theories. How could science be so successful if the theories weren't, latching onto something real?
It would seem like a miracle.
Exactly. The realist says the best explanation for this success is that our theories are, at least approximately, true. Think about how we accept atoms and molecules now that fits the realist picture.
Okay, but then there's the other side, anti-realism. What's their take?
Anti-realism offers a more, let's say, cautious interpretation. It suggests that scientific theories are primarily valuable as tools.
Tools for what?
Tools for predicting and explaining the phenomena we can observe. From this perspective, the unobservable entities that the theories talk about, electrons, quarks, whatever, they aren't necessarily real in the same way a chair is real.
They're useful concepts, constructs.
Useful constructs, exactly. Theoretical posits that help us make sense of the observable world and make accurate predictions. The theory works, it's incredibly useful, but we don't need to commit to believing that its description of the unobservable parts is literally true.
So anti-realism isn't saying science is bad or wrong.
Not at all. It's just questioning what the aim and achievement of science is. Is it literal truth about everything, seen and unseen? Or is it about creating empirically successful models? Anti-realism often leans towards the latter.
And this view often links back to empiricism, right? Focusing on what we can actually experience.
Yes, knowledge from sensory experience is key for many anti-realists. It also connects to instrumentalism, the idea of theories as just instruments. And a really important point from the sources is how anti-realism often confined itself to that theoretical layer.
What do you mean theoretical layer?
It means we accept the theory because it works brilliantly for predicting observable outcomes, the stuff in the lab, the readings on the instruments. But we remain agnostic or even skeptical about whether the underlying theoretical entities it talks about directly map onto some hidden reality. They're part of the predictive machinery, maybe not reality itself.
Okay. And what arguments do anti-realists use against realism? The sources mention a couple of big ones.
Two really important ones are the pessimistic meta-induction and the underdetermination of theory by evidence.
Okay, let's break those down. Pessimistic meta-induction. Sounds gloomy.
It kind of is. It looks at the history of science. Think about theories that were once incredibly successful, widely believed, great predictive power, like the phlogiston theory for combustion, or the caloric theory of heat, or the idea of the ether that light supposedly traveled through.
All discarded now.
All completely discarded. The argument is, if history is littered with these highly successful theories that turned out to be fundamentally wrong about the underlying reality, why should we be so confident that our current successful theories won't suffer the same fate?
Past failures make us pessimistic about present claims.
That's the idea. And then there's underdetermination. This is more of a logical point.
Okay.
It suggests that for any set of observational data we have, it's always possible, at least in principle, to come up with more than one theory that perfectly explains all that data.
Even conflicting theories.
Potentially, yes. Theories that might posit different underlying mechanisms or entities, but still fit all the observations we've made so far. If that's true, the evidence underdetermines the theory. It doesn't point uniquely to one single true theory.
So how do we choose which one reflects reality if multiple theories fit the facts?
Exactly. That's the challenge underdetermination poses to realism.
And the sources mention constructive empiricism. Is that a specific type of anti-realism?
Yes, it's a very influential view developed by Bos van Frassen. It's a sophisticated form of anti-realism. Van Frassen argues that the aim of science isn't truth, full stop, but empirical adequacy.
Empirical adequacy, meaning?
Meaning the theory saves the phenomena. It accurately describes and predicts everything we can observe. According to constructive empiricism, we should accept theories as empirically adequate, but we don't need to believe in the reality of the unobservable entities they talk about.
So you use the theory, you accept it works for observations.
But you remain agnostic about whether the quarks or wave functions it describes are actually out there.
Mm.
This really highlights that anti-realist focus. Success in the observable realm doesn't force belief about the unobservable theoretical realm. The theory is a great tool for prediction, not necessarily a window onto reality's hidden structure.
It definitely sounds like more than just a simple yes or no to realism. The sources mention lots of variations.
Oh yeah, it's a whole spectrum. Naive realism, entity realism, believing in the entities but maybe not the theories fully. Structural realism, believing the mathematical structures are real. It gets quite detailed. It's a rich debate.
And then on top of all these philosophical debates about interpretation, there's the practical messiness of doing science, like bias.
Right. The sources call them the invisible influencers. Bias is a huge practical challenge.
What kinds of bias are we talking about?
Things like selection bias, how you choose subjects or data, confirmation bias, our tendency to favor evidence that confirms what we already think, measurement bias, publication bias, studies with positive results getting published more often, sampling bias. Lots of ways human factors and methodological choices can creep in.
These aren't necessarily scientists trying to cheat, right?
No, often not at all. There's subtle influences that can skew results even with the best intentions. There are inherent challenges in trying to get objective knowledge through human effort and limited methods.
But science has ways to fight back against bias.
Definitely. The sources cover key strategies like randomization, randomly assigning subjects in a trial, for instance. That helps distribute unknown influencing factors evenly.
And blinding.
Yes, blinding is crucial, especially in medical trials. Single blinding means the participant doesn't know if they got the real treatment or a placebo. Double blinding means neither the participant nor the researcher interacting with them knows. It prevents expectations from influencing outcomes. Control groups are also fundamental.
So acknowledging bias doesn't mean science is broken. It actually shows science is aware of the pitfalls.
Exactly. It underscores that scientific knowledge is constructed through specific methods designed to overcome these very real human and procedural limitations. Understanding bias gives you a more realistic picture of how science actually works.
Okay, let's try to pull this all together. We've gone from the basics of philosophy of science, looked at how science develops theories from observations, and really dived into this central realism versus anti-realism debate.
Asking whether science gives us reality or just really useful predictive tools.
And we've touched on the practical challenges like bias. So how does exploring all this, using the sources you provided, help someone think right about science?
Well, I think the main takeaway is that it provides you with a framework to avoid oversimplification. You don't have to just blindly accept every scientific claim, nor do you have to cynically dismiss all of science.
It gives you nuance.
Exactly, nuance. You can appreciate the incredible strengths of science, its power to explain and predict, while also understanding its limitations and the philosophical questions surrounding its claims, especially about unobservables.
So you can understand that a theory like, say, quantum mechanics can be seen in different ways.
Precisely. A realist might see its equations as reflecting the deep structure of reality. An anti-realist, perhaps following constructive empiricism, might say, wow, this theory is incredibly empirically adequate, its predictions are amazing, but I don't need to believe space-time is really quantized, or that wave functions really collapse in the way the theory describes to accept its predictive power.
It lets you hold those different interpretations in mind. Understanding that success, particularly predictive success for what we can see, doesn't automatically equal a true description of hidden reality. That's the core of the anti-realist caution about the theoretical zone.
Yes. And grasping that spectrum, that tension, that's what develops that sophisticated and nuanced way of thinking about science and the reality or anti-reality of science and scientific theories that the source is aimed for. It's about understanding the different ways we can relate to scientific knowledge.
And this isn't just academic. This helps in everyday life.
I think so. When you encounter scientific news or debates about policy based on science, or even just making personal health decisions, having this philosophical grounding helps you ask better questions.
Like, what kind of evidence is this based on? How strong is it? What are the underlying assumptions? Is this claim about observables or unobservables?
Exactly. It equips you to be a more critical, informed consumer and user of scientific information.
Okay, so here's a final thought for you, the listener, to chew on, drawing from all this. If we lean towards an anti-realist perspective, maybe seeing scientific laws less as discovered truths of the universe and more as our incredibly effective human-constructed tools for prediction. Does that change how you view the universe itself?
Are we discovering the rules the universe plays by? Or are we just getting really, really good at inventing games that let us predict its moves?
Yeah. Does the universe obey Newton's laws? Or are Newton's laws just a fantastic description of how things seem to move in certain conditions? It's a different feel, isn't it?
It certainly is. Definitely food for thought.
A lot to think about indeed. Thanks for joining us on this deep dive, exploring these fascinating ideas from the material you brought to the discussion.